In this video, we're going to talk about Kruskals' algorithm, which is one of many algorithms to find a minimum spanning tree of a graph. So in the last video, we talked about what a minimum spanning tree is. Now we're going to talk about how you might algorithmically find a minimum spanning tree in a graph. Here is a big view of the algorithm. First, you're going to remove all edges from the graph. You're going to repeatedly find the cheapest edge that doesn't create a cycle and add it back. And in the end, the result will be the MST of the overall graph. So here's the graph that we'll look at. We are going to first remove all of the edges and add them back in order of cheapest to most expensive. So the cheapest edge on this graph is the edge 1 here on the far left bottom of the graph. We're going to find the lowest cost edge that doesn't create a cycle and add it back into the graph. So this is an example of the lowest cost edge that doesn't create a cycle, so it's going to be added into the graph. Now we're going to get to the next lowest cost edge in the graph, which is 2. There's only one other edge with 2. It does not create a cycle, so it gets added back in. Then we go to 3. So you can see that there's actually there's 2 that have the weight of 3. So obviously based on how they're ordered, you might have a different, you might have one or the other come up first. So here we're going to add 3 in. It doesn't create a cycle, so we add it. Now we go to the other 3. It also doesn't add a cycle, so we add it. Now we get to 4. 4, if we were to add this 4 edge to our graph, it would create a cycle here. So that means that it won't be added, so it's ignored. We go to the next 4. Here it doesn't add a cycle, so we add it, and then another 4. And here's an example of, again, this would create a cycle here, so it's not going to be added. But a graph can have many minimum spanning trees, so there's not necessarily just one. And so here, the choice of length 4 edge that we visit first would lead to different results. So if we were to visit this one first rather than this one first, then we would have added this edge here, and we would have not added this edge here. So there could be different minimum spanning trees. So we're going to ignore that one. So we go to another 4, we add it. Now we go to 5, we have this one, we add it. This one, we don't add it because it would add a cycle. This one, we add it. Down here, we're going to add 6. That would create a cycle, so we remove it. Another 6. That would create a cycle, and that cycle would be created here. So that has to be removed as well. We have this 6 that would create a cycle here, so that's going to get removed. This one is also going to create a cycle because it would create this cycle, so that one is going to be removed. And then we have the 7s, so this one is added, this one is not added because it's a cycle, and this one is not added because it's a cycle. So we have our MST after completing the algorithm. So that's the general idea of the algorithm. A key step in Kruskals' algorithm is basically determining whether or not edges are already connected to each other. So how to actually do this, one option is to create something called clusters. So basically each node will start off as its own cluster, and then whenever an edge is added, the clusters for the endpoints are merged together into a new cluster, and that can help determine whether or not determining whether or not edges are already connected to each other. So here's like a rough idea. I'm not going to go through the whole algorithm again on this graph, but you would start off with each node having its own color, own cluster, and then as you're doing the algorithm that we just did, every time you connect a node to a cluster, you add it to that cluster. So here this is like 5 or 6 steps into the algorithm, we've made some connections, and so all of these are connected, so they become one cluster, and then we have another cluster over here. Everything else has not been connected yet. And as you add in the algorithm, here's another midway point where this has all been added now at this point, so this is all one cluster, but these still haven't been added in. Then eventually, once you have one cluster remaining, you know that you have a minimum spanning tree. So the algorithm basically looks like this. You place every node into its own cluster, and you place all edges into a priority queue. So again, that's where the tie breaking of tied weights is going to come into play. While there are 2 or more clusters remaining, you dequeue an edge from the priority queue, and if its endpoints are not in the same cluster, you merge the clusters containing the endpoints, and you add the edge to the resulting spanning tree. And then at the end, you'll return a resulting spanning tree. So that's the general idea of how the algorithm works. So it's a really nice algorithm, very clean, and a cool application in graphs. So what I'm going to talk about in the next video is different applications that can make use of determining the minimum spanning tree of a graph.